So in this video, we're going to be solving the June 2009 Regents Part A and Part B1. So hopefully you did this in advance, and hopefully this video helps you. So the first problem is a car that's driven on the highway, and we're asked to find the average speed. So average speed is the distance traveled divided by the time that it takes to do that. And we're going to do the total distance divided by the total time. So we have 80 kilometers for the first 1 hour, 50 kilometers for the next half an hour, and then 40 kilometers for the next half an hour. So that gives us a total of 170 kilometers, and it takes us 2 hours to do so. And if you do 170 divided by 2, you get your 85 kilometers per hour. Number 2, it is looking at a vector, and we're asked to find the vertical and horizontal components. So we're going to set up a right triangle and do some trigonometry. So if we're trying to find the vertical component, that is the opposite side. We have the hypotenuse, and we have the adjacent side. So to find the opposite side, when we have the hypotenuse, that's going to be your sine function. So we're going to do sine of 35 degrees equaling the vertical component of the force divided by the hypotenuse of 24 newtons. Okay, in order to find the adjacent side, we're going to set up cosine of 35 degrees equaling the horizontal component divided by 24 newtons. And when you plug that into your calculator and cross multiply here and cross multiply there, you get choice 4. 20 newtons for my horizontal force and 14 newtons for my vertical force. Moving right along, vector. Vector is a quantity with both magnitude and direction. So the magnitude part is how big, how fast, how much. The direction is which way is it going. So some of these are kind of operational. So speed and time don't have a direction, nor does power. Impulse is the only quantity that depends upon which way you push something. Impulse is the force acted over a short period of time. So impulses are a vector. Number 4, we have a high-speed train travels a distance of 300 kilometers. We're trying to figure out the average speed. So we have speed equals average speed equals their distance divided by time. Now we have a little bit of a conversion that we have to add here. We have 300 kilometers. So kilo in your reference tables gives you 10 to the third, or 1,000. So I'm not going to put in 300 kilometers. I'm actually going to put in 300,000 kilometers. And I'm going to divide that by the time of 3.6 times 10 to the third seconds. And if you plug that into your calculator, you get your 83.3 meters per second. Number 5, we have a 25 Newton weight falling freely from rest from the roof of a building. What is the total distance the weight falls the first 1 second? Okay, so if you remember that the 25 newtons, does not affect the acceleration due to gravity, because all objects accelerate at the same rate regardless of weight. So it says it's dropped from rest, so that means my initial velocity is 0. I know that it's falling in the Earth's gravitational field, so I know it accelerates at 9.81 meters per second squared. And I'm looking for the distance in the time of 1 second. So if you look at your reference table, something that's got your d, vi, a, and t, you'll find d equals vit plus 1/2 at squared. And if your initial velocity is 0, that cancels that out. And if we're looking for the distance, then it's just 1/2 times 9.81 times 1 second squared. So that should get you 4.9 meters. Number 6, we have a golf ball is given an initial speed of 20 meters per second and returns to ground level. So which launch angle above the ground level results in the ball traveling the greatest horizontal distance? So we did a lab with the marble launchers, and we looked at range, which is the horizontal distance, versus angle. you remember, we got a graph that looked like that, where the maximum range happened at 45 degrees. Okay, and also that if we don't have a 45 degrees, we notice that actually is a choice, so that works out. But then we can also see that that point, let's say, looking at 30, would have the same horizontal distance as something like 60, because they're both 15 degrees away from 45. So the general trend is as the angle gets going up to 45, the range gets larger, and then from 45 to 90, the range gets smaller. But time spent in the air, the maximum time spent in the air, continues to go up as the angle goes from 0 to 90. Okay, so 90, firing something straight up, will go higher, spend more time in the air. And that conceptually makes sense. Number 7, we got a go-kart traveling around a flat horizontal circular track with a radius of 25 meters. The mass of the go-kart, the rider, is 200 kilograms. Okay, the magnitude of the maximum force exerted on the track of the go-kart is 1,200 newtons. So we have a centripetal force of 1,200 newtons. We have a radius of 25 meters, and we have a mass of 200 kilograms. So the equation, we're asked to find in number 7 the maximum speed. So the equation that relates forces with velocities is F sub c equals mv squared over r. Doing a little bit of algebra, we get r times f over m, and then square root that, equals my speed. And if you plug in those numbers, you get a value of 12 meters per second. Number 8, what change would increase the maximum speed at which the go-kart could travel around the track? Well, if you look at the equation, mv squared over r, if I want to increase this maximum speed, I want to either increase the force, okay, or increase the radius. Either one would increase the speed. So now I just want to look at which one is one of the choices. Okay, and the only one that is one of those choices is increasing the radius of the track. Number 9, we have a 0.5 kilogram cart is rolling at a speed of 0.4 meters per second. If the speed of the cart is double the inertia of the car, okay, the inertia of the car depends upon the mass, and that would go unchanged. Okay, nothing's changing about the car. So that will be all for now. Check out video 2.